Good afternoon. We are working today on lesson 81. It is reducing fractions. Now, you're going to find that this looks extremely familiar to making equivalent fractions, but it is actually the exact same, only working in reverse, working opposites. So, lesson 81, reducing fractions. Now, the best thing I can do to help you understand what we're doing here today is to remind you of our Superman. Now, when we go from Clark Kent to Superman, we would take a fraction like 2/3. We send it into a phone booth of 1, a fraction that equals 1, like, we'll say 4/4. We multiply it. 2 times 4 is 8. 3 times 4 is 12. So we've sent Clark Kent into the phone booth. He comes out as Superman. Now, lesson 81 is taking Superman and shifting him back to Clark Kent. So where we go this way to find equivalent fractions, we're going to go this way to reduce the fraction. So if I said 8/12, our Superman is going to go into the phone booth of 1 and come out reduced. Well, what is the opposite of multiplication? Hopefully your head right away said, oh, that's easy, Mrs. Gomes, division. Yes! So if we say, what goes into 8 and 12? Well, 4 goes into 8 and 4 goes into 12. So we're going to send him into the same phone booth. So 8 divided by 4 is 2. 12 divided by 4 is 3. So what we've done here is we have reduced it to the lowest terms. Go ahead and put that in. Lowest terms. Now we can tell we've reduced it to the lowest terms because when I look at the 2/3, there is no number that will go evenly into 2 and into 3. So we have sent him back to his complete Clark Kent self. So that's all reducing fractions is going back into that phone booth of 1, coming out fully dressed like Clark Kent. Again, remember, the 8/12 and the 2/3, they are equivalent fractions. This is just the Superman version, and this is the Clark Kent version. Now let's take a quick look at exactly how we figure what we're going to reduce it by. If I were to say 6/8, well, I'm going to ask myself, what is the number that will go into both 6 and 8? Well, 1 doesn't count because that sends them in and comes out exactly the same, 1/1. So I would say, well, 2 does go into 6 evenly and 2 does go into 8 evenly. So if I say 2/2, 6 divided by 2 is 3. 8 divided by 2 is 4. So I need to find the number that will go into both elements evenly. Now sometimes you're going to end up with a fraction like 6/7. And I'm going to ask you, what goes evenly into 6 and into 7? Well, nothing. There is no number that goes evenly into 6 and 7. So this cannot be reduced. It is already at its lowest terms. So remember, when we reduce it, we want to get it to its lowest terms. What number will go into both the numerator and denominator evenly? Now let me show you what happens when you reduce it, but you're not getting the biggest number that goes into both. Write down the fraction 8/12. Now, if I ask you what goes into 8 and 12, both 8 and 12 evenly, you may take the easy way out. And you say, oh, that's easy. They're both even numbers, so 2 goes into both of them. Okay, that's right. 2 over 2 equals 1, so we're good. 8 divided by 2 is 4. 12 divided by 2 is 6. Wait a minute. Have we gotten this to its lowest terms? Or is there a number that will go into 4 and 6 evenly? Hopefully you went, oh, yeah, there is. And you would have 2 over 2 again, because 2 goes into 4 and 2 goes into 6. Well, 4 divided by 2 is 2. 6 divided by 2 is 3. Is there anything that goes into 2 and 3? Nope. Now you got it. You are at your lowest terms. Now let's look at that. What if you would get the biggest number that goes into both of them evenly? Well, 2 goes in. Is there anything bigger? Well, how about 3? No. Does 4 go into both? Aha! 4 does go into both evenly. 8 divided by 4 equals 2. 12 divided by 4 equals 3. Is there anything that goes into 2 and 3 evenly? No. Look, I reduced to lowest terms in just one step, as opposed to up here having 2 steps. I will be honest and tell you I really don't care. So long as you end up reduced in the lowest terms, that's fine with me. It's easier to find the largest number that will go into both, but it doesn't really matter so long as you are reducing it to its lowest terms. Okay, let's do our final one just to practice it up. Let's try 16 over 20. Go ahead and reduce it out. You can take the easy way, the first number that you can think of. You can sit and think it through to say what's the biggest number that goes into both. But take just a moment, figure it all out. I will wait patiently a few moments for you. I want you to know I feel like humming the Jeopardy sound, but I won't. Have I given you enough time? You get just a little bit more. Okay, I think I've given you enough time. Now, you could have done one of two things. You could have gone the easy way, which is 2 over 2. 16 divided by 2 is 8. 20 divided by 2 is 10. Ask yourself, is there something that goes into 10 and 8 and 10 evenly? Yes, there is. That would be 2. 8 divided by 2 is 4. 10 divided by 2 is 5. I have reduced it to its lowest terms. The other option you could have done is 16 over 20. Don't have to rewrite these because hopefully you did one of them correctly yourself. 4 over 4. 16 divided by 4 is 4. 20 divided by 4 is 5. Reduced to lowest terms. Now always just make sure when you hit this spot that you ask yourself, is there a number that will go into both of those numbers evenly? Even when you get to the end, make that your final check. Just in case you missed something along the way, is there any number that would go into the 4 and 5 evenly? No, there is not. And that, my dear ones, is reducing fractions. Going from Superman to Clark Kent. Have a fabulous evening, and I'll see you to play with this a little bit more next day. Have a great night.